Good morning, guys. Welcome back. So it seems like we left off in number 11, right? Multiple choice, Barron number 1. All right, let's see how many we can get done. Hopefully, the remaining of part A. Which of the following series converges conditionally? Okay. If we're going to be checking conditionally convergence, then we're going to be looking to see if maybe the absolute value of the series converges. So for the first one, we're going to have 3 to the power of n divided by 2 to the power of n, which you can think of it as 3 over 2 to the power of n. Now, this is a geometric series, and because r is greater than 1, the series is going to diverge. Number 2, again, think about taking the absolute value, leaving us with 1 over n to the power of 1/3. Here we have a p series. And because p is less than 1, well, less than or equal to, the series is going to diverge as well. Number 3, this one can be compared to 1 over n to the power of 5. It's a p series. P is greater than 1, so it converges. Now, converging conditionally means that the absolute value of the series diverges, but the original one converges. And the original ones technically all converge because of the alternating series test. So which ones converge? Oh, wait, just kidding. The first one doesn't converge. The first one also diverges, even if we look at the alternating series test. Yeah, because the numerator is growing faster than the denominator. So the only one that converges conditionally would be number 2. Number 12. If x equals 2 sine of theta, then this integral can be equivalent to, all right, well, let's go ahead and take our 2 sine of theta and plug it into x. All the x's. And you know what? There's a little typo in the problem because, oh, wait, never mind. Here it is, dx. I didn't see it originally. Okay, yeah, let's go ahead and change our limits of integration as well. To be extra safe, take the 0 and plug it in. Plug it into the equation that you're going to be using for x. So my new limit of integration is going to be 0. Then when you plug in pi over 2, your limit of integration should be 2. No, wait, I did this wrong. I did it backwards. Sorry. I'm plugging in 0 into theta, but 0 is not theta. Here, I'll do it again. This is x. So 0 equals 2 sine of theta, because now we're looking for theta. Take the sine inverse, and you're going to get 0. Okay, that one didn't change, but the other one will change, because you have 2 equals 2 sine of theta. 1 equals sine of theta. So pi over 2 equals theta. See, there we go. All right. For the expression, we're going to have 4 sine squared of theta. 4 minus 4 sine squared of theta. In my denominator, we can factor out a 4. Oh, one last thing. I still have a dx, right? And we're changing everything from x's to theta. I mean, look at your choices, right? They all say d theta. So let me take that step right now. If x equals 2 sine of theta, then dx d theta is going to be 2 cosine of theta, which means that dx is going to be 2 cosine of theta d theta. So we're going to go ahead and replace the dx for all of this. We're going to do a lot of steps in this one. 1, we're going to take the square root of 4, this guy. 2, we're going to use a Pythagorean identity to replace 1 sine squared of theta for cosine squared of theta. And 3, like I had said, the dx is now going to be 2 cosine of theta d theta. Yeah, that was a lot of steps. Let's go ahead and finish the problem. 4 divided by 2 is 2. The square root of cosine squared is cosine. And then the cosines cancel, leaving you with 4 sine squared of theta d theta. The answer here is B. Lots for us to do. Number 13. Okay, number 13, I believe, had a typo and I didn't catch it the first time. I fixed it already. But originally there was a 4 in the front. So, I mean, I took it off because the 4 should have never been there, according to the answers anyways. Either that or the answer should have been different. But here's how you do it. The antiderivative from -1 to 1. Here's one way to do it, right? I saw some other students do it different ways. But I'm going to go ahead and graph 1 minus the absolute value of x. My y-intercept is 1. The slope is 1. So it's going to bring us down here to 1 and -1. So now the integral from -1 to 1 is going to be, I'm going to find it by doing 1/2 base times height. The base is 2. The height is 1. The answer is 1. But this is not the only way to do it, because when you're working with the absolute value, you could technically split it up into 2 integrals. I'll show you, but I won't finish the problem. One of the integrals would be from -1 to 0. And if you look at that linear function, we have a y-intercept of 1 and a function that has a slope of 1. So technically, it would be 1 plus x. And we get that plus x because when you remove the absolute value, you technically get a -x, right? That's where the 1 plus x comes from. And then we also have the integral from 0 to 1 of 1 minus x. So take off the absolute value and you get a positive x. This corresponds to the second line that has a slope of -1. And then you can do the antiderivatives for both. 14. Here we have a twice differentiable function. Find the limit. Well, I mean, I think that we find the limit originally, it's probably going to be undefined. So I'm just going to go straight to L'Hopital's. And don't forget the limit notation. The limit as x approaches 1 of 2f prime of x minus 6g prime of x divided by 8x minus 4e to the power of 3x minus 1. Okay, and apply the chain rule correctly here. Times the derivative of 3x minus 1. Or you can think of it as 3x minus 3 if it makes it easier. But that's just going to be times 3. Okay. F prime of 1 is 0. G prime of 1 is -2. Well, we're going to have e to the power of 0, which means that we're going to have 12 over 8 minus 12. And it looks like it's going to be negative 3. If you were doing this on an FRQ, don't go straight to L'Hopital's. Calculate the limit first and see if you get 0 over 0, right? You have to show that. It's multiple choice here, so I'm just kind of going kind of quick. As quick as the video allows me. Number 15. What is the volume of the solid generated by rotating the region enclosed by the curve of y equals 3 over x? Okay. 3 over x will look kind of like this. So we want to rotate the region enclosed by the curve by the x-axis from 6 to infinity. So let's just say 6 is here. So we're going to get all this area, right? Well, technically, volume, because we're going to be rotating it. To find volume, we're going to do the integral of the area of the cross-section from 6 to infinity of pi r squared. The radius is going to be given by the distance from the original function to the center of revolution. So 3 over x pi r squared dx. Now, again, if you were doing this in an FRQ, you do need to set up the integral and maybe do something like this. The limit as b approaches infinity of the integral from 6 to b of pi. So that's going to be 9 over x squared. But I'm going to write it as 9 times x to the power of negative 2, just so that I'm ready to, integrate. Okay, so here we have the limit as b approaches infinity of 9 pi. And then my antiderivative, you add 1 to the exponent, and you divide by the new exponent. Well, this gives us negative 1 over b minus negative 1 over 6. And when you take the limit to infinity, the first part becomes 0, and the last part stays 1 over 6, which means our answer is 9 pi over 6, or 3 pi over 2. There was another typo in this question, guys. I'm sorry. Next time I'll do the test beforehand so that I can double check everything. There it is. Number 16. If a equals the integral from 0 to 1 is approximated by using various sums with the same number of subdivisions, and we're using a left Riemann sum, a right Riemann sum, and a trapezoidal sum, which one is true? Okay. Well, first realize that what they're giving us is basically 1 over e to the x. So you have to know your graphs, or maybe get a sketch out of them. E to the x is an exponential function that grows, but 1 over e to the x is a function that is decreasing, right? When you take the limit to infinity, this is going to be 0. So the graph should look something like this. Okay? So keep that in mind. Now, if I did a left Riemann sum, it would look like this. An overestimate. And now the bigger you do your subdivision, the more clear it's going to be. So what if I did a right Riemann sum? It's going to be an under approximation. And if I did a trapezoid, so let me extend my graph. If I did a trapezoid, I don't know if it's going to be so clear with this graph that I just did. Here, let me try to fix that. Make it decrease, 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 decrease. Okay. If I did a trapezoid, it's going to be from here to here, but it's a straight line. Hopefully that kind of shows it. So I guess the question is, right, which one is bigger? Well, L is the biggest. The trapezoidal sum is always going to be better than one of the Riemann sums in terms of approximating, but in this case it is under. So then it's trapezoid and then the right Riemann sum. But finally, we also have to include the actual area, the perfect area, no gaps. And because the trapezoidal sum still leaves a gap, the area is going to be bigger than the trapezoidal approximation, leaving us with B. This is not always true. Test your theories with the graph, right? Or know your rules about how Riemann sums behave with increasing, decreasing functions. Concave up, concave up, concave up and down. So, yep. Number 17. dy dx is equal to y tangent of x. Y is equal to 3 when x is 0. Then what does y equal when x equals pi over 3? Okay. Well, first thing you want to do, separate the variables. Then, what you want to do is take the antiderivative. The antiderivative of tangent, that's a little tricky. Tangent is technically sine over cosine. So if you did your u substitution using cosine, your du would be negative sine of x dx, which means that dx would be du over negative sine, which really means you're integrating negative 1 over u du, which gives us negative ln of u. So my antiderivative here is negative ln of cosine of x plus c. Okay. Y is 3 when x is 0. And cosine of 0 is 1. And ln of 1 is 0. So there's your c. But we're not done. Here. Let me take this off. I need a little more space. So now I have that ln of y equals negative ln cosine of x plus ln of 3. And now we want to figure out what y is when x equals pi over 3. Cosine of pi over 3, cosine of 60, that is 1/2. Okay, get rid of ln by using e. Yeah, let's just keep working here. Separate the variables or separate the powers by using the properties of exponents. And I'm going to do one more thing. You see this negative right here? A logarithm property allows me to take it and put it back as a power. So we're going to say that it's going to be ln of 1/2 to the power of negative 1. And the sum of powers becomes the product of bases. Here we have ln of 3. This now allows me to cancel these guys. leaving me with 1/2 to the power of -1 times 3. This gives me 2 times 3, and the answer should be 6. Okay. Okay, we're getting close to the end. I'm not going to be able to finish, but it's okay. The parametric equations x and y give the position of the parametric of a particle moving in the plane for t is greater than or equal to 0. What is the slope of the tangent line to the path of the particle when t is equal to 1? Okay, if we're going to find the slope of the tangent line, we're going to have to find the derivative of y divided by the derivative of x. Okay. The derivative of y is going to be 1/2 times 2t to the power of -1/2 divided by the derivative of x. We have cosine, apply the chain rule, times 2t. Okay, and you know what? I'm going to go ahead and plug in 1 already. These cancel each other out, leaving me with 1 over the square root of t. But like I said, I'm plugging in 1 already. Cosine of 4 times 2. I can't really do cosine of 4, so that's just going to be 1 over 2 cosine of 4. The answer is B. Okay, let's see if I can make it a 20. In which of the following series can the convergence or divergence be determined by using the limit comparison test? Well, I mean, if I didn't have the choices, actually, sorry, this is already the simplified version. Ignore that. For A, if I wanted to use the limit comparison test, I would have to compare it with something like, I mean, these would cancel out in 5 over 2. It doesn't make sense. B, if you ignore this guy and you simplify, you could have 5 over 2n, or maybe even 1 over n. So, no. C, again, ignore the small fry. Simplify the power functions. 5 over, nope, just 5. 5 divided by 2n, which again really could be 1 over n, so no. Ignore the small fry. Simplify the power functions. N squared and n to the power of 4. That simplifies to this. And technically, you can even ignore the coefficients. So yeah, it's going to be D. That's the one we can use the limit comparison test for. 20. Find the slope of the curve. Oh man, this might be a long one algebraically. Okay, I'll give it a go. If I'm going to find the slope of the curve, just like with parametrics, we have to find the derivative of y with respect to theta and the derivative of x with respect to theta. But y is equal to r times sine of theta, and x equals r times cosine of theta. Okay, so my derivative yeah, you know what? Let me find r prime right here. R prime is going to be negative 2 sine of 2 theta. I'll just kind of keep it in the back of my head right here. So anyways, y prime, first times the derivative of the second plus the second times the derivative of the first, or x, again, the first times the derivative of the second plus the second times the derivative of the first. And now we want to plug in pi over 6. So r, if I plug in pi over 6 right here, I'm basically doing cosine of pi over 3, which is 1/2. Cosine of pi over 6 is the square root of 3 over 2. Sine of pi over 6 is 1/2. And if I plug in pi over 6 into r prime, which is this guy, that should be, you know what, let me ignore the negative 2. Let's just plug in pi over 6 to sine of 2 theta. That should be square root of 3 over 2. Okay, we already plugged in pi over 6 into r. We did it here, so the same thing's going to happen here. That's going to be negative 1/2. I plug it into sine, I get 1/2. Plug it into cosine, we get square root of 3 over 2. And if I plug it into r prime, we already did it, so it's going to be the same. Oh, wow, a lot of fractions here. This equals the first term, square root of 3 over 4. The second term is cancel, leaving us with negative square root of 3 over 2. In the denominator, get negative 1/4. These cancel, leaving us with 3 over 4. Hey. Maybe I shouldn't have canceled these 2's over here. Because I'm gonna have to get a common denominator. Let me backtrace. This was negative 2 square root of 3 over 2. And without simplifying anything out right there, let me just see that it's going to be 2 root 3 over 4, because now I have common denominators. This gives me negative root 3 over 4 divided by negative, Let's see if this is true. Because I think I made a mistake here, guys. Let me backtrace and look at my work. Negative 1/2, root 3 over 2. Maybe not. Maybe I didn't make a mistake. Let's see. Let's just keep going. And if I multiply by the reciprocal here, well, technically that's negative 1, so it's just positive, right? Yeah, no, I made a mistake somewhere. Where did the mistake happen? Where? Oh, I found it. Same thing in the denominator. I shouldn't have canceled out these 2's, because that's just gonna mess everything up. See, that should be over here. It should be negative 2 times 3 over 4. There we go. Negative square root of 3 over 4 divided by negative 7 over 4. Now I can multiply by the reciprocal. These cancel and we get square root of 3 over 7. All right, guys, that's gonna do it for right now. I gotta run. Thank you very much.